Welcome to today's Explainer. I am so incredibly excited to guide you through this topic. We're going to be tackling an absolutely terrifying scientific thought experiment. But don't worry, my goal today is to give you a really neat and clear explanation, keeping things completely to the point as we break down the exact physics of a global catastrophe step by step, using data straight from our sources.
So, let's just dive right into it. Picture this scenario. Right now, with absolutely no warning, no countdown, and zero earthquake alerts on your phone, our planet just stops. A complete, instantaneous halt for exactly 5 seconds. Does life just pause for a moment? Do we all just kind of catch our breath? Well, the short answer is no. According to the scientific calculations we reviewed, Hollywood disaster movies look like a literal walk in the park compared to what would actually unfold here.
To understand exactly why, we got to look at this one massive number. Right now, as you're watching this explainer, you are traveling at roughly 1,670 kilometers per hour if you're anywhere near the equator. You obviously don't feel it, but that is our baseline speed. And that speed, right there, is exactly what turns a seemingly innocent 5-second pause into a totally apocalyptic event.
To keep things neat and clear, here is our roadmap for today. First, we'll cover the physics of spinning. Then, the sudden stop itself. Third, the reaction of wind, water, and earth. Fourth, the deadly restart. And finally, the real future of our planet.
All right, let's jump into Section 1, the physics of spinning. Basically, why do we move in the first place?
To understand why we spin, we actually have to rewind 4.6 billion years back to when our solar system was just this giant, messy cloud of gas and dust. As gravity pulled all this dust together, a really fascinating physics principle took over, called angular momentum. Think of it like this. When a rotating object shrinks, it spins faster to maintain its energy, and because there is no friction in the vacuum of space to slow it down, well, the Earth has simply kept that original rotational energy. We've literally been spinning non-stop since the day the planet was born.
Now you might be wondering, if we're spinning so incredibly fast, why on Earth don't we just fly off into space? It's basically a massive cosmic tug of war. The centrifugal effect, which is created by that spin, is constantly trying to push us outward, but gravity, pulling us tightly toward the planet's center, is overwhelmingly stronger. Gravity anchors us down so perfectly that the centrifugal force is virtually unnoticeable to us. Which brings us to Section 2, the sudden stop, hitting the planetary brakes.
So, why don't we feel that massive speed right now? Think about being inside an airplane, cruising at 900 kilometers per hour. You can walk up and down the aisle completely normally because the cabin air is moving at the exact same speed you are. Earth is basically our airplane, and the atmosphere is our cabin. But what happens if that airplane hits an invisible brick wall in the sky? Sir Isaac Newton's law of inertia dictates that a moving object stays in motion until a force stops it. If the Earth's solid ground suddenly stops, that law immediately decides the fate of everything on the surface. Let's look at this really stark contrast. The Earth's crust hits the brakes, but the atmosphere, the oceans, cars, buildings, and you don't hit the brakes. You keep moving east at 1,670 kilometers per hour. Just imagine you're driving on the highway at 120 kilometers per hour and someone suddenly slams the brakes. You jolt forward violently, right? Now, scale that up to 1,670 kilometers per hour with zero seatbelts. Anyone just sitting in an office would instantly become a kinetic projectile, launching sideways like a missile. It's truly mind-boggling.
Actually, scratch that, I should clarify one quick thing here. That 1670 number, that's at the equator. As you move closer to the poles, the rotational speed drops. So, places like Canada, Scandinavia, and Antarctica would face a slightly lower kinetic impact. But make no mistake, while they might not hit the absolute maximum speed, the kinetic shock is still a completely fatal civilization-ending event everywhere on the globe.
Okay, moving to Section 3, Wind, Water, and Earth. Let's look at the rapid systemic collapse.
Let's walk through this rapid-fire timeline of our 5-second disaster. In Second 1, humans, cars, and untethered objects are launched sideways. By Second 2, the atmosphere, which is still moving at orbital speeds, creates supersonic winds that just obliterate infrastructure. By Second 3, the oceans, acting on that exact same inertia, surge forward as mega tsunamis. And by Second 4, the immense braking friction causes the tectonic plates themselves to violently fracture.
Let's break down those winds with some hard data to put it into perspective. Scientists consider the massive dust storms on Mars, which hit about 160 kilometers per hour, to be incredibly dangerous. But the sudden stop of Earth? That would generate winds exceeding 1,000 kilometers per hour. We're talking about winds faster than commercial aircraft, hitting concrete buildings, glass skyscrapers, and steel electric towers all at the same time. Forests would be uprooted instantly, and any aircraft in the sky would be completely destroyed as airports turn into instant disaster zones.
And while the wind is devastating, the absolute most powerful force on Earth, water, would react next. Billions of tons of ocean water in the Pacific, Atlantic, and Indian Oceans would just keep moving forward due to that inertia. This wouldn't be just your average flood. We're talking about mega tsunamis. Ports, beaches, and coastal highways would vanish instantly, and the water would violently push miles inland, completely erasing coastal civilizations in literally seconds.
Meanwhile, right beneath our feet, the illusion of a solid planet shatters. The Earth's crust is made of tectonic plates, and stopping them suddenly triggers unprecedented global earthquakes. Gas pipelines erupt, power grids completely collapse, and chemical plants fail. Interestingly, though, our satellites up in space would actually survive, because they rely on orbital velocity and gravity, not the Earth's surface rotation. But down here on the ground, the stations would be wiped out, meaning your GPS and all global communications would instantly go dark.
This takes us to Section 4, the deadly restart, the secondary kinetic shock.
So the 5 seconds are finally up. The Earth starts spinning again. You might be thinking, this is the moment we're saved, right? But you'd be wrong. The restart is absolutely not a return to safety. It is a massive secondary kinetic disaster. Think about it. Everything has just violently smashed forward. Now the ground suddenly accelerates beneath all that wreckage again. A second massive shockwave rips through a planet that is already entirely in ruins, hitting systems that are now completely out of balance.
You see, the Earth isn't just a rock floating in space. It's a delicate, deeply interconnected system. The atmosphere, the oceans, the global temperatures, they all rely on continuous, steady rotation. That sudden stop and restart permanently breaks that entire system. Energy is violently redistributed. Jet streams and ocean currents that dictate our weather are completely destroyed, and the climate equilibrium that we basically rely on to grow our food and survive is permanently shattered.
The ultimate environmental consequence of all this is a permanently unlivable, deeply divided climate. With the atmospheric flow ruined, a really harsh reality sets in. One hemisphere of the planet would be scorched by extreme heat, baking under the sun, while the other side would be plunged into an instant, brutal ice age. Even if anyone somehow miraculously survived the physical kinetic impacts, the ruined environment would for sure finish the job.
Okay, let's take a collective breath and move to our final section, the real future. What actual, factual science tells us.
So, everything we just talked about, that's the terrifying fiction. But bringing it back to reality, the Earth is not actually perfectly stable. According to scientific data, the Earth is slowly decelerating. It is literally slowing down right now as we speak. But thankfully, it's not happening in 5 seconds. It's slowing down by mere milliseconds every single century.
In fact, if you go back billions of years ago, a single day on Earth was much, much shorter than the 24 hours we experience right now. Our planet is constantly changing, constantly reshaping itself. The crucial difference is that the real universe operates on these vast, slow, gradual timescales, keeping us entirely safe from the apocalyptic 5-second scenario we just explored.
Which leaves us with this final takeaway. We've seen how absolutely reliant we are on the hidden, massive physical forces perfectly balancing our world every single day. So I want to leave you with a question to think about. If a tiny, incredibly slow change in rotation safely dictates the grand timeline of our climate, what else about our planet's future is quietly being rewritten today, right beneath our feet, without us even noticing? Think about that for a bit. Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you in the next one.